Today we're going to take a look at key features of parabolas, and this is really a vocabulary and comprehension lesson. So vocabulary in mathematics isn't just about definitions and using them in sentences, but it's being able to identify them visually. And parabolas are nothing more than graphed quadratics. And so standard form of a graphed quadratic or a parabola is ax squared plus bx plus c. The same standard form when we were solving or factoring quadratics. Now, parabolas can have two distinct shapes. So, as I'm drawing out my graphs here, we have both positive and negative parabolas. So positive parabolas, let me do this in blue. Positive parabolas point upwards, or we say they open upwards, and this is called a positive parabola because the A value, or that starting value, is positive. And we have negative parabolas that open downward or point downward, and we call these negative parabolas because they start off negative. So the x squared, that coefficient starts off negative. Now, when you graph any parabola, there are a couple pieces of information that we can identify just from the graph. So let me get a graph up here. So just a plain old coordinate grid. And just a basic reminder that this is referred to as our y-axis. The vertical axis is y, the horizontal axis is our x-axis. And for this example, I am going to be using a positive parabola. So they can be wide, they can be skinny, they do not have to pass through the origins. I'm actually going to draw one here, like so. So I have a parabola, and just looking at the graph, I can identify my solutions or my zeros. Now, my solutions here, or these particular points on the graph, can be referred to in one of four names. It can be referred to as the solutions. It can be referred to as the zeros. But these are also called roots and x-intercepts. So any of those words are interchangeable, and what they're referring to are those points on the graph that intersect with the x-axis. And just like we have a point that intersects with the x-axis, we also have a point that intersects with the y-axis called the y-intercept. Now, every parabola has a high point or a low point, and that is referred to as the vertex. Vertex simply means turning point. And if we're looking at a parabola, our vertex is either located at the very bottom, or it's located at the very top of the graph, depending on where that graph turns. So positive graphs have a low point or a minimum, and a negative parabola has a high point or a maximum. So you can also refer to these as max and min, or maximum values and minimum values of your parabola. Now, what's really fancy and nice about that vertex is that, remember back when we spoke about transformations and folding something in half? Parabolas also can be folded in half, or they are symmetrical. And this invisible line is referred to as our axis of symmetry. So just like during reflections, we had an axis of symmetry, and it will always be an equation that starts with x equals, because it is a vertical line that passes through the vertex. Now, what's really nice about it is if my vertex is located at x, y, then my axis of symmetry passes through the x value of my vertex. Now, in order to kind of look at these, we are going to be using Desmos. So I've got Desmos set up right over here. So I'm going to just put in a positive graph. So y equals x squared, let's say plus 8x plus 15. So you can see this is a positive graph. My a value, so the value in front of x squared, is positive. So it's going to open upwards. I have my zeros, or my solutions, also called my roots, my x-intercepts, right where it crosses the x-axis, at -5 and -3. So if you were to solve this using the quadratic formula, or you were to solve this by factoring, your solutions would be at -5 and -3. I also have a y-intercept. If I zoom out, my y-intercept is located at 0, 15, so this is where it crosses the y-axis. And the lowest part of my graph is also identified. What's nice about Desmos is it drops all of those points for you. So my vertex is at -4, -1. If I look at this graph, my vertex happens at the very bottom, at the lowest point on my graph. So this is called our minimum. And if I look at the x component of my vertex, I have my axis of symmetry. So x is equal to -4. And I'm going to turn that into a dashed line. And you can see, let me make that just a little bit darker. You can see that that axis of symmetry passes right through the middle of my graph. So those are key features, basic key features, a lot of vocabulary, but the vocabulary here is not definitions as much as just being able to identify where the information falls on a graph. And in the next lesson, we're going to take a look at, okay, if this is what my zeros are, what do they mean in real life situations? Or how do I use my vertex when working with projectile motion, or the axis of symmetry, or that y-intercept? What does that mean if I was to throw something off of a table? So understanding the vocabulary is going to help us be able to apply quadratics and parabolas to various situations.